Um, our next speaker is Sarah Kingsbury. Sarah is the Senior Aquatics Invasive Species Biologist at Fisheries and Oceans Canada in Nova Scotia. She specializes in freshwater non-Indigenous species, but also has many projects in marine ecosystems. Sarah works with eDNA and genomics, screening level risk assessments, climate matching, and framework development. Sarah completed her MSc thesis at St. Mary's University in Halifax, and she was studying the Chinese mystery snail, which the first time I heard of the Chinese mystery snail was from a presentation by Sarah about 6 years ago. Her Bachelor of Science in Chemistry was completed at the Royal Military College in Kingston, Ontario. Sarah is a member of the Nova Scotia Invasive Species Council Steering Committee and one of the NSISC's founders. Sarah, I can see your screen. You're on mute.
Hi,
And I can hear you too, so I'm just going to turn that right over to you. Thanks, Sarah.
thank you so much. Okay, I'm just going to try and advance. Perfect. All right, I think it's all working. Yeah, feel free to stop me if something's not looking right. Before I start too, I just wanted to take a moment to acknowledge that my research is happening throughout Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. I wanted to thank the Indigenous communities of Nova Scotia for their continued stewardship of all the aquatic ecosystems that I have the privilege of working in. I also wanted to acknowledge all of my co-authors. So you can see there's quite a long list of co-authors that worked on this project. And it was a team effort for sure. And I'm just lucky enough to have the opportunity to present about it today. So why hulls or why marine vessels? We know since about 2012, Nova Scotia has been experiencing an annual influx of new marine invaders every year, and hulls of vessels connect Nova Scotia to other parts of the world. So they're a way in which species are brought from ecosystems that they're maybe indigenous to or already invaded into, and bring them into Nova Scotia. We know that hull fouling and ballast water are two of the most common methods or pathways that an invasive species is brought to Nova Scotia. In Canada, Transport Canada regulates ballast water through the ballast water regulations. They also offer some voluntary hull fouling guidelines for vessel owners about keeping their hulls clean. Those guidelines are applicable to vessels over 24 meters in length. So we were in this project focused on vessels less than 24 meters in length. Some good news, it's not all doom and gloom. Technology is getting a lot better every day. So there's new hull fouling paints coming out, and they have better technology and better efficacy of keeping hulls clean for longer periods of time. We also are constantly learning more about biosecurity and what could that mean for Canada, and what are the methods in which maybe we could implement in Eastern Canada to help decrease the pressure of new marine invasive species arriving. And although we don't have a lot of signage in marine ecosystems around invasive species in Nova Scotia, there are other countries and states and provinces that have started enacting these signs just to kind of educate the population about what species they might find in their area. And it's a great way to start raising awareness. There's also robots that are getting better and better every year at sticking to hulls and then automatically cleaning them off without releasing invasive species into the water column during that cleaning process. So there's a lot of good news behind the technology development and potential like regulators, but we weren't really sure what solutions would work for Nova Scotia because different invasive species might need different solutions. So we had two parts of this project. The first part was in 2024. And before we could really start looking at hull fouling on a broader scale, we first needed to see what types of equipment we would need to look at hulls. Our team is fairly small. There's about 2 to 4 of us at any given time. So we can't really do big operations like diving. So we had to find other methods to look at hulls. without needing to actually enter the water. And then the other big question is it really worth our time? Like I said, our team is really small, so we have to be careful with how we focus our time and resources. So in 2024, we visited 4 sites around Halifax Harbor, just trying to get a general understanding of what the equipment could be, how well it handled, and also if hull fouling was a big issue, like how bad is it actually? And then in 2025, following that pilot study, we expanded this project further because we were interested in looking at potential spatial distributions of invasive species. So um, there are natural biogeographic barriers that exist in the environment where salinity or water temperature, light penetration, whatever it is, the ecological components of that habitat change so drastically that species can't naturally cross those barriers. And we were interested in seeing if there was then any spatial differences in the hull fouling communities that we were looking at. So we started in Digby and visited small craft harbors, yacht clubs, and marinas between Digby all the way up to Halifax. We also wanted to see if maybe vessel type was indicative of the type of fouling or the extent of fouling. And the last thing we wanted to see was what type of species we're finding on the hulls and what the common fouling species was, because whatever solution could potentially be put in place in the future needs to be useful then for the common fouling species. So on the right side, I just have some pictures of the equipment that we use. In 2024, we used this kind of pole and GoPro on a stick with some lasers on either side. And we also had a light. And then in 2025, we got this new system, which was basically the same thing. It's still a telescoping pole on a coax cable that connects between the GoPro and our phone so that we could watch what we were doing underwater. But the big difference is that the pole that we got in 2025 was much longer, so it could reach further around the hull. There was more points that we could turn or modify the angle of the camera. And it was also made of fiberglass, so it was a lot lighter and nicer to work with. And we upgraded our camera from a Hero 8 GoPro to a Hero 11 GoPro. So that really improved the photo quality and our abilities to be able to identify species. What we did was at each of these harbors, we would go and collect some videos of vessel hulls. So typically the videos were between 30 and 90 seconds. We had a minimum standard of doing 3 vessels per harbor. And we're always trying to focus those videos on vessels less than 24 meters in length to kind of fit within the scope of our work. Um, for each of the vessels, we took at least 2 videos. So one of the bow and one of the stern. And that's just because you can get different types of hull fouling species depending on the curvature of the vessel. So also, whenever possible, we also would take videos of maybe the side of the ship or any niche areas, so propellers or rudders, or if there's a double keel, we take a video of that. Just any place really that a ship would fold in the water, because that's where you start seeing buildup of hull fouling. We also recorded a little bit of information about the vessel. So type of vessel, if we knew the hull type or could guess it, that wasn't always possible, but sometimes you can tell, it's a metal hull, fiberglass, wood, just some kind of general information. We estimated the vessel length and the purpose. So by purpose, we were meaning more like if it was a fishing vessel versus a motorboat, or even within fishing vessels, sometimes we're able to break it down to a more refined category of seaweed and kelp harvesting versus lobster fishing, for example. So we would go and do these surveys each morning at all of the marinas. And then that evening, we would either be at a lab or hotel room during our field work. And we would download all of those videos from our GoPro onto the laptop and create automatic screen grabs from each video. So that was a script that we wrote in R, and it just automatically takes a screen grab every 5 seconds in the video. All of those screen grabs would be saved to a group folder, and we could review all of the photos to see if they were clear enough for us to do the species identification from the screen grab. Sometimes the screen grab would be at a part where maybe we were moving the camera too quickly, and so it was out of focus. In those cases, we would go back to the video and try and take a manual screen grab from roughly the same time. And we had a minimum standard of 5 screen grabs or 5 photos from each video. All of those photos were grouped together and then uploaded to an online free software called Beagle. And Beagle lets us annotate on the picture itself. So we upload the picture and we can add points or squares or circles to help identify the species on that hull or within that picture. And once all of those annotations are done, that data gets exported again as a CSV file that we can enter into a statistical software like RStudio to do some type of summary statistics and look at trends in hull fouling. So these are all of our sites. Like I said, we visited 20 sites and looked at 75 vessels. So there was kind of a even grouping between fishing and motor boats. We did find less sailboats to survey, so we only unfortunately had 12 sailboats that we could look at, but still, a good representation. And we really had a variety of sizes. So all the way from 3 meters long up to 46 meters long. Basically, all of the vessels were between 3 and 24 meters in length. Like I said, we wanted to stay within the scope of our project. That 146-meter long vessel was a mega yacht that we just opportunistically found at one of these sites. And the vessel owner was really generous and wanted to see what was under their vessel. So we agreed to do some videoing for them. And that's that 46-meter long. Overall, we had 841 photos that we analyzed. And these pie charts offer you a summary by site of what we saw in the hull. So you'll see some of these sites, you're more likely to find some type of algal species on them. Some sites may be more bryozoan. The pie charts that have more of that red circle color means that there was more invasive tunicates found at those sites. And then purple is mollusk, which is a general categorization, but really most of the mollusk ones were blue mussel. So there's a lot of variety by site, and this box and whisker chart just kind of summarizes it at a by site level versus the extent of fouling. We were curious to see if there was any significant difference in the amount of fouling that we see by site. And what we found is that it's a common problem. All sites had fouling of some kind. I put a little star by Sambro right here, 2024. So this was a site that we visited in both years. So we visited in 2024, and then we went back in 2025 and did the exact same survey in the same site. And only Sambro surveys from 2024 had any significant differences with other sites versus the one from 2025. The surveys from 2025 didn't have any significant differences, and there also was a significant differences between 2024 and 2025. So what this tells us is that hull fouling is a common problem across all sites, and that common problem, even within the site, happens on a spectrum. So you can find vessels that are minimally fouled and vessels that are extensively fouled within the same site. We didn't find any significant difference based off of the vessel type. So fishing boats, motor boats, and sailboats all had the same extent of fouling. So likely the extent of fouling is more linked to that ecological context and how routine the cleaning is by the vessel owner. We did find some significant differences in the size class of the vessel versus the extent of fouling. So larger vessels and that mega yacht were more likely to have less fouling than medium and small class vessels. But you can see down here where it gives all of the number of vessels surveyed by size class, that we just happen to find more in that medium size class. And it's also demonstrated here in this box and whisker plot. There's a lot of outliers. So again, there's a big range of hull fouling happening, whether it's by site or size or class of or type of vessel. I really don't think we can draw conclusions on targeting one specific group based off of the extent of fouling, because it really is a common issue across all of these categories. And there's a lot of variety in the data. What we can see for a very clear result is that Siona intestinalis, or the invasive base tunicate, was by far the most commonly found hull fouling species. And behind that, you see things that are like hydroids, some macroalgal species, so biofilms, filamentous algae, eelgrass, and kelp. We also found those common on hulls, and then after that is maybe native blue mussel species. But by far, it was Siona intestinalis that we found most commonly on hulls. And you can see here in this photo, this is from the Sambro 2024 survey. And you could just see this is like a sea of Siona on someone's hull. And they just packed so closely together that there's almost no space for anything else to grow. You can kind of tell there's this little orange part here. So that's probably violet tunicate that's growing either on or in between the vase tunicates. We were able to get a subset of data from a hull fouling survey that was done on a larger scale, so across all of Eastern Canada, and it looked at hull fouling on small craft vessels between 2009 and 2014. So what we did is just pull out some of the sites that were similar, like very close in proximity or exactly the same as the sites that we surveyed in 2024 to 2025, and could compare the community composition between those two surveys. And you could see there's a clear shift away from biofilms and barnacles towards hydroids, vase tunicates, violet tunicate. We also found a golden star, but those become more and more common, it seems, in our recent survey. So potentially over time, even though we're not seeing a drastic shift between the site that we sampled in 2024 to 2025, there's no significant difference. But when we look over multiple years or over a collection of years, we are seeing shifts in that community composition, and we are finding more invasive species on hulls now. So what does this mean when you take it all together? Like, what's the big picture? I would say that the main takeaway is about this spectrum of hull fouling. And I tried to add some photos here to demonstrate the spectrum. So at the very top here, we have some minimal fouling on a hull that we surveyed at Bedford Institute of Oceanography in Dartmouth. So you can see there's some little white patches all over it. Those are probably barnacles or some type of encrusting hull fouling, but you can see the paint that that hull through the fouling, and it's very minimal. There's not a lot of growth on that hull. Whereas this vessel in Lunenburg, you can see there's a lot of biofilm buildup on it, and these little orange circles potentially are Schizosporella japonica, which is a type of invasive bryozoa that we're finding more commonly in Nova Scotia. There is a native species that's similar looking, so it's potentially the native species, but we did find a lot of the Schizosporella bryozoa throughout Nova Scotia this summer, so I'm more inclined to think that it's probably that one. And then on the bottom here, I gave two examples of extensive biofouling. So you can see, well, maybe not super well, but there's a ton of vase tunicate. And underneath it, there's some type of encrusting fouling. It looks like most likely it's blue mussels and biofilm. that then the vase tunicate potentially grew on. But then even on top of the vase tunicate is providing structure for colonial tunicates to grow on. So all of these yellow, orange, this is a purple patch here. These are all different color morphs of violet tunicate, which is another invasive tunicate. And down here in the corner, I'm not sure how well you can see it, but there's golden star tunicate growing as well. So there's layers and layers and layers of fouling happening. We also see it here. This one maybe has less lighting, so it might not be as obvious, but we found a vessel that was so fouled in Armdale that it was like a living reef. There's a sea star here, not in this photo, but we did have some video captures of fish that were living off of this hull, almost like it was a reef, and this was their home reef that they're living from. So it was really extensively fouled. And then, like I said, there's changes over time in the community composition, but it's not very evident year to year to year. There's some changes between the years in the quantity of each species that's occurring on hulls, but not as much between the type of species. Um, any cleaning solution that could potentially be put in place to limit the spread of invasive species on hulls would need to be applicable across a number of taxa, so macroalgae and tunicates, and likely whether or not a hull is clean or less clean or more clean probably has more to do with when the last time that hull was out of the water, whether or not the anti-fouling paint is scratched or when it was last applied, some environmental conditions, like if there was a massive rainfall in that area, sometimes that can kill off species on hulls, and also access to resources, financially or otherwise, that can be used to clean that hull. Overall, we found that public education was a really important gap that we're finding in the marine hull fouling communities. The people that we talked to at these wharves, they were very curious. The vessel owners loved the video idea. They loved being able to see under their vessel. I think it's maybe hard sometimes to get under a boat and see what's growing on the hull of a vessel. And so having these videos that we were taking from the floating wharf or the dock beside their vessel was just a really accessible way of engaging that vessel owner. Um, a lot of the vessel owners, though, weren't clear or even believing that they had contributed or could contribute to the spread of invasive species. We had some people saying that, well, if an invasive species is here, it's going to spread everywhere, which we know is not true because of those biogeographic barriers. They weren't really sure about how ocean currents, predominant ocean currents, could act as a barrier as well to invasive species to naturally spread. And they really weren't sure about how sticky invasive species can be on the hull. Many of the people we talked to said, well, once I get up to speed, all of that's just going to fall right off my hull. Definitely some of it will fall off the hull, but not all of it. So that was another piece of information that we were happy to share with these groups, but was clear that needed to be shared a little more. The photos from this work tell a story more than our words ever could. So on the side here, I have a photo of a hull that we took in Metagan, and it looks like a healthy ecosystem, but it's not. It's actually someone's vessel, and it's so foul that it looks like an upside down benthic habitat. So it was just a really interesting way to explain to people, this is what your hull looks like, and it really is contributing to or could contribute to spread of invasive species because it's so extensively fouled. We didn't see any or many signs at wharves or within the communities discussing or notifying the public on invasive species that they were likely to see in their area. So that would be a nice thing to fill. And importantly, any type of cleaning solution or regulatory measure that's put in place um, needs to be accessible to everyone. And we found that the solutions that are currently typically available to groups are not socially, physically, or economically available to everyone who's there. And so when you take into account that not everyone can do this type of cleaning, it really limits the our ability to prevent spread through marine ecosystems. And the longer we wait to take action, the more likely this problem is to get worse, as we showed with the comparison with the 2019 to 2014 surveys. Compared to our surveys, we're seeing more and more invasive species on the hulls now. Okay, that's all I have. I just wanted to say a big thank you to all of the groups that helped us. I did leave my contact information here, so if anyone has questions or wants to reach out or get involved, please contact me directly. Thank you.
Thanks, Sarah. Sarah was nice enough to show us some of those videos to Sherry and I a while ago, and man, it's just incredible to see how much is on there, and those photos show it as well. I have tons of questions, but we'll see if anybody else has any first. It was a pretty thorough presentation, so there's no questions yet. Sarah, I was just wondering, because I know, having a boat myself, or up until recently anyways, that at marinas, like the marina where I would keep my boat, some boats hardly move all summer. Like, they go in and they come out. And I'm just wondering if, I guess, asking how much that boat has moved would help understand, like, if it hasn't moved very much, then what's growing on it is probably an indication of what's right there in St. Margaret's Bay or Shearwater or wherever you are. And if it's moved a lot, it may be collecting. Any thoughts on that?
Yeah, we definitely did see between some vessels that were removed less frequently had a lot more fouling than vessels that were used more frequently. That could just be because the people who own those vessels are cleaning it more, so there's less fuel consumption and cost to the owner. But you're right that if a vessel is only staying within their home marina, then whatever's on their hull is more likely to be a reflection of what's already in that marina. And so we're a little less concerned with that, and we're more concerned with vessels that cross those natural biogeographic barriers and can be a catalyst to spreading invasive species.
Right. And then one other thing that crossed my mind is that I know, just from talking to some lobster fishermen, that lobster fishermen are going out a lot further. Now they're going out to like Sable Island around there and staying out there for 2 or 3 days. And I just wonder if that might, if that would create, differences in the data compared to what the previous research had.
Yeah, I don't know. It could, like, there's always the potential when a vessel goes to a new place, and especially when they stop or go alongside and then stay there for a pretty long period of time, it's possible that they're picking up whatever is in that other location and bringing it back to their home port.
Mm.
Um, but we didn't find any differences between the fishing boats and the motor boats and the sailboats that we surveyed. So as far as lobster fishermen versus, pleasure craft, we can't say for sure like who is bringing more invasive species to where. We did have some lobster fishermen that we talked to in South Nova Scotia say that they take their boat out of the water to let everything die off before they move between lobster fishing areas or LFAs, just to save on fuel costs, which is a great reason also for people to clean their vessels.
Right, right. So there are a few, 3 questions in there now. I think we have time for one, and then perhaps you can address the other one. And the briefer one is, how does the fouling impact vessels' movement through water?
So the more friction created in the water, the more the cost is to the vessel owner to pay for gas and whatnot. So there's
Yeah.
definitely a financial burden to the owner. And practically speaking, too, you just want to have a clean hull because it makes your ride a lot smoother. So there's a lot of good reasons that people would want to clean their vessels, and definitely taking your vessel out overwintering it on land instead of in water could help decrease the amount of fouling on your vessel when you start the season again. But as soon as a vessel touches water again, the whole process starts. So there is going to be buildup over time as long as it's in the water.
Yeah. All right. Thanks so much, Sarah. That was great.
Thank you.